All right. Uh, Hello. So as introduced, I'm Oskari Saarenmaa, the CEO and founder of Aiven, a cloud technology company providing open source data systems as managed cloud services. With me here on the stage is Gerhold, who's working on strategic opportunities at Comcast. We'll be talking together about how Comcast is using Apache Kafka on Aiven to power their IoT platform for home automation. So we'll start by discussing some of the challenges in IoT event processing, and then move on to talk about Apache Kafka and how it's fit for these use cases, and how you can operate and use it in cloud environments, and how to run it efficiently, and how other companies around the world are doing it. I'll then give the stage to Andrew, who's going to be talking more about Comcast and Xfinity Home, and some of the objectives and requirements and challenges they had when building the platform. We'll then move on to the future vision of the platform, and we should have some time for a couple of questions at the end of the talk. Also happy to follow up on these just at our booth behind that wall behind you. So moving on to get started around what's the IoT event processing challenge. Like when we were building an IoT system, typically the architecture consists of devices, edge gateway, and a business logic backend running somewhere in the cloud. In this picture, we have a home environment that has multiple different sensors and active devices that are transmitting data to the cloud, and there's some sensors that are just producing passive readings around temperature and so forth. And then there are also some active systems such as light switches and doors and door locks and so forth that really require you to be able to quickly ingest those events and respond to them. So we need a platform that allows you to quickly and efficiently ingest tons of different kinds of events from different data sources and respond to them with an end-to-end latency of less than a second when we're talking about things like light switches, where the end user doesn't want to really wait for a minute for their lights to turn on after they come home. So we need a really scalable, high-performance event bus for working with all of these events. Now, there have been all sorts of message buses and message queues around for a long time, and you'd think that many of them maybe could be a good fit for the use case. However, many of those systems have shortcomings when it comes to platform scalability or platform evolution, where you want to be able to add more workflows on top of the event streams without having to change and modify all of the sensors and IoT devices already installed in homes and businesses and so forth. So when we'll compare different ingestion solutions for handling these events, Apache Kafka really stands out. It's an open source event streaming platform that was originally built by LinkedIn and open sourced in around 2011. It's now used in production by lots of different kinds of companies around the world for powering their IoT and analytics use cases. So in addition to LinkedIn, it's nowadays used by, for example, Spotify and Square, Twitter, and of course by Comcast. The key thing that makes Apache Kafka suitable for these kinds of IoT use cases is the way it decouples event producers from event consumers. So producers in our example are, for example, all the sensors and devices in a home environment that must just send their readings and their events into a backend system running somewhere. But they shouldn't really have to care too much about what's going to use those events and what's going to respond to those events. So they just need to be able to efficiently and quickly transmit those readings to a backend system. Then there's the consumers, which in our environment are these data processors in the cloud which are responding to these actions or readings from the devices. So the way Kafka organizes things is we have these producers writing an event stream into a concept called topics. Topics allow you to organize all of your data in the backend by use cases, and also allow you to split it into partitions, enabling massive scalability of the data. So you can have millions of different devices producing into different kinds of topics, and you have your set of consumers, which are these stream processing engines that are responding to those events. And you can add more of these as your platform evolves. So what Kafka enables is really a rapid evolution of the platform, as you don't have to decide upfront how you're going to be responding to these kinds of events. The difficulty with Kafka comes with the operational burden of actually having to run it and scale it in the cloud. So it's a really great system for handling large number of events, but when you have to operate it, you typically require specialized expertise that's not readily available, which is why we wanted to build a cloud service that really allows anybody out there to get access to an efficient Kafka environment in the cloud. So millions of businesses are already building new applications and new technologies and products around use cases where some of these interesting open source technologies are very beneficial, but they really shouldn't be in the business of having to manage those systems and having to set them up and make sure that they scale with their user base while staying secure and available. So what we've built at Aiven is a cloud platform that really has you covered on all fronts. So you can just focus on your application innovation and building your IoT products, while we take care of running the platform for you. So it's a really no-ops environment where you get access to production-grade clusters in a couple of minutes, and we provide a 4.9 SLA by default for all of our users. And security is also a big concern for many use cases. Security is built into the platform where all data is always encrypted, both at transit and at rest. We are also compliant with ISO 27000 and SOC 2 requirements, so this allows you to deploy the platform with confidence in various different environments. What we built at Aiven is a cloud platform turning the best open source tools and technologies into managed cloud services that are readily available on any major cloud out there and in all of the regions of these clouds. So we bring all of these technologies to the cloud regions that are closest to your clients and users, so you can have low latency when accessing the systems. In addition to Kafka, we're currently operating several other open source data and database engines on Aiven, and we are always looking at new things that are coming to the market, and by using Aiven, you can be sure that you are always keeping up with the innovation in the open source ecosystems. We started building Aiven in around 2016, and with a team of industry experts in Helsinki, Finland, where we're headquartered. Our team previously built large-scale production environments for companies like F-Secure, Nokia, and Google, and all of that expertise helped us create a scalable, efficient cloud platform that's now used by hundreds of customers around the globe. We are now providing operations support for more than 500 customers across around 50 countries around the world from our 4 offices in 3 different continents. So we're today working every day with great companies like Comcast on making sure that they are able to move efficiently and quickly in the cloud with these leading open source technologies. I'll now give the stage to Andrew, who's going to be talking about Xfinity Home and some of the requirements they had for the platform.
Cool. Hi there. All right, so I'm Andrew. I work with Comcast. We had an interesting challenge, right? We're trying to build a product that scales to millions of customers with millions of devices. We're trying to present that in the home. Everybody is looking for automation, right? You see automation all around you here and at home, right? In your car, on the devices that you wear every day. And one of the unique challenges that we had, we were in a space that, we're on the TV, right? And so we're already inside of people's homes. And we thought, how can we maximize this space by building a product that really connects people together? It really brings their lives that they come home, they want things to happen on a schedule, they want to be efficient about the way that they run their AC. And this is one of the unique areas that Comcast has expanded into, that we have been able to build really technologies that take advantage of emerging fields, just like IoT. So a few of the key objectives and requirements here are around latency, right? As Oskari talked about, you don't want to say, when I walk into my home, then turn on my light, and have that happen something like 7 seconds later. That sort of defeats the purpose of the ability to walk up to your home and carry a bag of groceries and have your door unlocked, because it knows that that's who you are and allows you in. You don't want to be waiting there, okay, come on. You need it to happen almost immediately, and we're trying to provide that. And in a distributed environment, when you're dealing with scale and all number of ways that the internet can just simply mess up, it's difficult to try to build that reliably. And one of the ways that we're able to do that is with these technologies now that are message buses, right? These high performant message buses. But like he was saying, some of them can be difficult to operate in a manner that requires something like 99.9% availability. When you have a break, like a window break alarm, and you want that to go off and notify you immediately or call the cops, you need that to happen in a highly available way, right? It almost must happen if that's the service that you're providing. And these services and their scalability in terms of how available that they are really make that happen for us readily. And then of course, like what we're trying to do is allow users to set these routines up in their daily life. When my child logs into her stream app, and what is she watching, right? Let me know. When I open the front door, turn on my light. When it's 6 p.m., schedule my AC to turn on, to create like a more efficient and connected home environment for our users. So when we talk about the challenges of working with, do you build this at home? How many pieces do you take from open source and combine them together to make the product that you're looking for? How do you really build this thing, build the guts of what it is that you're trying to accomplish here? You have to think about, there's edge computing, right? You're going to have these sensors, and then you're going to have a hub that they talk to, and then you're going to have a number of different devices along the way. And how do you build this in a manner where the protocol is small enough that you can reach these low latencies, that you can assure that these messages are going to get to where they need to go in a reliable time frame? Do you build in dead letter queues? How do you manage this, right? How do you take this platform that you're building of all of these different components of software and wire it up into a web UI? Is that the most efficient tooling for your operations team to use? And then you've got security, right? Security is becoming one of the most foremost concerns, including all of the legislation that has just been put into California from the CPP and the GPDR. These things are important to our lives, and they're important to everybody else as we see them being presented in our legislatures. So it's important that we also have security around this type of data. This type of data is unique. It tracks you essentially at what you do, what your regular routine is like. It's something that you want to help you, but at the same time you need it protected. It should live close to you. And also time to market. So in all of these challenges, whether you decide to build something at home or whether you decide to use a vendor like Aiven, or just for small pieces, whatever your choices are, it's going to be critical that you are there for the competition, right? Everybody else is going to be trying to accomplish the same thing in the same type of market that you're trying to do. And time to market is absolutely key. Sometimes you must make decisions in order to reach the end goal by the time frame that you're looking for, and those decisions are going to be based upon the challenges that you face when you're in a competitive market. So what we did with our solution, right? Our end goal state was to say, we need Kafka in the middle, right? In our case, we needed a message bus that was sort of like the mission critical end state. That message bus was our central post office for everything that was going to happen inside of our system. So a sensor would go off, it would contact a home hub, and then that home hub would contact our message bus through a variety of different methods. But finally, everything that would happen once those messages reached that message bus was all disseminated down from there. All of the actions that customers would be listening for, right? The sensor data that they would want to integrate into their lives and would perform on schedules. All of that would trickle down from that message bus, as we could then learn from that data that we see, have users interact with that data and really take it in, apply it to their lives, and automate the way that they're, automate the way that they want to live their life in the home.
Can you talk a little bit about the protocols you use for ingesting the data?
Sure. So the number of protocols change depending on the type of device that's being used, right? Some devices use a different protocol as they need a streaming ability in order to get data quickly, and other devices use a more metadata-rich protocol that allows us to enrich the data with events that we may find interesting for the users themselves. Finally, more often than not, we try to use protocols that are adaptable, right? The market changes all the time, and we expect Aiven to change with that market and provide us technologies that allow us to take advantage of those emerging protocols, if you will, as well. Because standards change all the time, right? We get a new standard every year. And if that standard just happens to be a better standard that we follow, then we'll need to be able to change quickly and adapt, just like the market will.
Cool.
Awesome.
Thank you.
Of course. So ultimately, we built a platform that allows us to serve millions of customers at a time. Millions of customers end up having more than one device, so you get n number of millions of devices in addition. It's great. I mean, we feel it's awesome. We offer a availability in our home automation service of something like 99.98%, which means that we can have less than 1 hour, 40 minutes, and 14 seconds of outages per year. It's pretty tight. It's something that we're very proud of. End to end, the whole solution performs in under 200 milliseconds, which we consider pretty fast. There's a number of different things that we do with this, but ultimately the performance is critical. And when we measured all the vendors that were out there in this message bus space, we measured them by their latency and their performance to accomplish this end-to-end challenge. As that was the metric that we felt was really impact users, was the experience of how it felt that, wow, these things are really happening, they're turning on when I expect them to. When I say into my voice remote, take a picture or show me all the times that a dog peed on my front lawn. We need that to happen immediately, and through their service that does. So that's something that's really great. It's something that we're very proud of as an engineering platform and all the folks on our team. And we just want to thank you guys for making that happen.
All right.
So, cool.
Excellent.
Do we have time for questions? Oh, we do.
Yeah. So, I think we wrapped up on the Xfinity state as it is today, and we're happy to answer any questions that you may have. So I think we have a couple of minutes for questions.
Yeah, what kind of companies do you sell this technology to?
Right. So a lot of the users on Aiven are using Aiven services and Kafka for IoT use cases or analytics. The actual industries are very different, so it's more about if you have tons of different devices that you need to ingest data from, then you have a requirement for something like Apache Kafka or a different kind of an event streaming platform, where we think that Apache Kafka is the best one currently. So we see applications around home automation, also around retail, logistics, and fintech. So there's quite a lot of different industries using these technologies. Many of the companies we work with today are ones that have been around for decades and who have already built these data-heavy systems in the past, but who are now wanting to move from this batch-based on-premises data processing environment into something that's much more fast, much more efficient, and do that basically real-time in the cloud.
Yeah, that's right. I mean, we actually see for events like message buses and Apache Kafka, you can see that all services in your company will provide data to you, and you often want to react in a way on business actionable methods on that data. So it's effective to try to tie many services in your company together so that you can listen to one event source and then correlate that with another event source. And when these things are happening in real time, then you can make a business decision based upon that data that you're listening to from all of your products if you can move in that method, as opposed to just one report that you're seeing from a product, one report that you're seeing from another product. Make this decision in a batched way, have the meeting later on, try to determine what actionable intelligence you can get out of that. You can build a system that with message buses that allow you to do that interactively as opposed to reactively.
Any other questions?
Let him do this. Great one.
Sorry. So the question was around do we build the applications and handle the application data model? The answer is that we provide all the software infrastructure tools for ingesting these events, but we don't build your applications and we don't enforce a strict data model there. So you're free to build applications in a way that fits your business needs.
Yeah, hey guys. The question is more around devices and whether or not the event buses and all the data is just from Comcast devices, or would it also include any of the third-party devices made possible through the Stringify and works with Xfinity type of orchestration? Is that part of this, or is it just the actual Comcast devices?
Right. So, I mean, you can imagine that the devices that you have, that you're producing, that are branded as your business, are devices that you're going to get more data from, more enriched data from the user and the experience and how they're using them. But it does, in fact, include as much data as third-party devices will allow us to, right? So, things like, for instance, your thermostats, your garage door openers, any number of third-party devices is going to, when they tie into your services, right, they will produce events, and then you'll be able to take the event data and ingest it along with anything else in order to try to say, all right, well, this works with your home hub that you previously purchased. That's sort of one of the challenges that you have when you're providing an IoT platform, is the ability to connect to all of the devices, right? You want one simple management platform for your home that allows you to go to one place and manage all of those devices, as opposed to having several different apps. The Xfinity Home platform will work with a number of devices that'll be branded Works with Xfinity, so you'll be able to see them. It won't come with, you can use this separate app, or you can use the Xfinity Home app so that you can have that one management portal. But yes, we try to work with and partner with as many third-party devices as we can to build out that easeability of just walking into Lowe's or Home Depot and then purchasing a device off the shelf. Thanks.
Are there any other questions?
All right.
Yes, we're good.
Thank you.
Thank you, gentlemen.
And so we are just behind that wall, so happy to follow up there as needed.